Hello, everybody. This is Dr. Sima Aiden. Today, I just want to simply go over the methylation a part of the genetic testing to explain to you. And as you can see in this page, there are 3 columns to the left of the page or report. And the first column that starts with RS and a bunch of numbers. This is basically the code for the gene that makes the product that you can see in the middle column. And the middle column, basically, as I said, is a byproduct of the genes. Basically, this one is folic acid receptor number 1, number 2, and then these are all the enzymes that eventually they help each other to make our methyl donors, basically. And the third column is the result for that person for each section, correct? So for instance, the gene, and before I go more into details, is that remember, the product that are in the middle column, it takes 2 genes, one from mom, one from dad, to express themselves to make the product, which is the enzyme or receptor or whatever it is, correct? So if that person gets both genes, either from mom and dad, healthy, the designation is negative, and the color coded is green. And then the second flavor is that if that person, okay, gets one gene that supposedly should give rise to folic acid receptor number 2 is mutated, and the other parent gives a healthy gene, and we don't know which parent would give which one. You know what I mean? Just want to let you guys know, because that's a question patient ask me very frequently. So basically the result is plus negative, meaning that the gene, the gene is half mutated and the product is, no, I don't want to say half functioning, but again, the function is not as robust. Like the function of the receptor number 2 is not as robust at this one, correct? The third flavor is when mom and dad each give mutated genes, okay, to make this enzyme that is MTHFR. So the designation is plus, and basically, and the color coding is red. And the functionality of this enzyme is as low as it can get. Okay? So one thing that is very specific about methylation, part of the Pro7, is that we are able to calculate if we have, like, for instance, 1 mutation versus 2 mutation in these receptors or some of these enzymes, to see how much of the functionality goes down, and we plug in those information into basically a specific formula, and we can tell that the productivity of the methyl production is like 40% or 60%. And I say approximate, and I'm going to explain to you why it is approximate, but but for sure it's better than nothing, because it is important for us to be able to dose and choose the type of the methyl donor that we want. So then the next slide, this slide basically, that's a graph that shows us, I want you to just focus, don't get overwhelmed by all of this. There are three areas that I want you to basically focus. One is 5-MTH methyl tetrahydrofolate. The second one is methylcobalamin, and the third one is SAMe. This graph shows, the function of all of these complicated names and acronyms and all of those things is that for us to get the bottom line of our methyl group, one from 5-methyl tetrahydrofolate, another methyl donor is methylcobalamin, and cobalamin is another name for B12. And the third methyl donor, that is the universal methyl donor, is SAMe. And as you can see, between methylcobalamin and 5-methyl tetrahydrofolate, this is the one that has a bigger contribution here of producing methyl, and this is the pathway that give rise eventually to 5-methyl tetrahydrofolate. As you can see, we can say, okay, like for instance, this enzyme, if the person has one mutation, the activity goes down by 10% or by 20% if there is double mutation. And we can calculate how much of 5-methyl tetrahydrofolate this person makes. And we don't have this number for methylcobalamin or for SAMe yet. Okay, that's why earlier I said we can approximately say that, okay, because again, this is part of the bigger picture, and we can only have the percentage for this part of it. And again, as I said, it's much better than nothing, and it again helps us to dose the methylation and also come up with the type of the methylation. Do we want 5-methyl tetrahydrofolate or methylcobalamin, or we want a combination, or we want only SAMe, all three of them? And then basically it has to do with the patient history, the labs, and also the result and the productivity of this part of the methylation process. Anyhow, I tried to keep it as simple as possible, and I hope I could make a difference in your understanding when it comes into methylation. And remember, know your genes and control your health.